dumb it down to like the intro today.
I can't find my Monday.
And then Monday we'll do like the harder examples. So integration by substitution. So far everything you've integrated has been easy. It's all been a polynomial, or it's been trig functions that you already know. The hardest thing you've had to do, I guess, is like the integral of the cosine of, say, 2x. And you didn't know because people got it wrong on the test, but this would have been, oops, the positive sine of 2x divided by 2 because it like reversed the chain rule. Well, what you were really doing was almost using substitution without realizing it. Let's see. So what substitution does is like, if you have a function within a function, you're going to rewrite this as an easier thing to integrate. Integrate the easy thing, and then like put back in, or substitute back in what you did in the beginning. That doesn't make any sense. Okay, what I'm going to do is I'm going to use the variable u, because it's just what gets used. And I'm going to pick u to equal some part of this function that will make it easier for me. I'll just go through it once and you'll see. So I'm going to pick u to be 2x plus 7. Because if u is 2x plus 7 and I substitute that, I'm going to get myself an easy problem to do. I'm going to get the integral of cosine of u, and it's going to be easy. But I can't just like do that without this next step. If u equals 2x plus 7 and I choose it to be that, I also have to figure out what the derivative of u would be. So if I pick u to be this, what would the derivative of that be? 2. And technically, it would be 2 dx. You're not going to need to worry about these notations a whole lot, but in the beginning, it's just good to show you exactly what's happening. So what I want to do is, I want to go over to my original problem, and I want to substitute the x stuff out and put the u stuff in. So that instead of having any x's, I have only u's and du's. I don't want any x's or dx's, I want all u's and du's. Which is easy to do, except my u is right here, but du equals 2 dx. I don't have 2 dx, I only have dx. So I'm going to multiply this whole thing by 2, so that I have a 2 dx. But I can't just like multiply a problem by 2. What can I do to make up for that? Divide by 2. So I could kind of multiply the problem by like 2 over 2. So I'm just multiplying by 1. And I'm going to take that division of 2 out to the front and make it multiplying by a half. So what I've done is I've just given myself an opportunity to rewrite this in terms of a different variable that's going to be simpler. But I couldn't just make it exactly what I wanted it to be without using algebra or using like math rules. I can't just multiply this dx by 2 without also multiplying by a 1/2 so that they would cancel each other out and I would just be back to where I was. So I basically can rewrite this as 1/2 times the integral of the cosine of u du. You don't have to write it that big in your notes.
If you go that big on this paper,
Should it really? So it's called substitution because I'm substituting. I'm taking out 2x plus 7 and I'm substituting in a u for it. And then I'm making all the other appropriate changes so that it is all now in u's and du's. And now this is an easy integral to take. So I have 1/2 times, what's the integral of the cosine of u? The sine of u plus c. Okay, this is an indefinite integral, meaning I don't have limits of integration, so I have a plus c on the end of this. So I go back now, and now I want to take u out. Okay, my original problem didn't have any u, so I don't want the answer to have a u either. I just go back and substitute in for u 2x plus 7. And then I add on this c. I don't need to have 1/2 c because c is just a constant, so 1/2 of it is still just a constant, and that's it. No, it wasn't. It was like 3.
so it's over. Round up.
Let's do it. Because it's awesome.
No, not why do another one, but you had cosine of u d u pretty much, and then you just add a half.
I had cosine of u dx, but then I would have had u's and x's, and I can't like do that. So I had to get rid of the dx by using the du for it, and that's where I needed the 2 and the 1 half.
Okay.
So like, all right, let's do one that's like equally as difficult, so not harder. Okay. Okay. You're gonna get pretty good at picking your U's, but in the beginning, it's like, what am I supposed to do? But I think about what's like my innermost thing. I have the sine of x squared times an x, but that x squared is like inside of the sine x, so I'm going to pick that to be my u. The other reason I'm going to pick that is because I have to be able to take the derivative of u and find that in my problem. So what's the derivative of x squared? 2x. Technically it's 2x dx. I just don't always have to include the dx, but I will now just to show you what's happening. Well, notice how they're, like if du equals 2x dx, I have the dx and I have the x already. What's the only thing I'm missing? A 2. I'm going to put a 2 in and multiply 1/2 in the front so that, God bless you, I have 2 times x times dx and 2 times x times dx is what I'm going to replace with du. And then x squared, I'm going to replace with u. So I'll rewrite it as the integral, the integral of the sine of u du. Do you get that substitution? Sounds stupid?
What if there weren't that x there?
You couldn't do it. Okay, if there wasn't that x, you couldn't do the problem. We can't take the integral of sine of x squared without that x already there. Whatever I get for du, I can always insert constants. I can always multiply by a 2 and then a 1/2, but I can't insert variables. So if I get a variable in the du that's not already here somewhere, it can't do it. That's why integration is so frustrating. There's not a whole lot that you can actually do. You can't, because then you're like dividing by x, and if x happens to equal 0, then you're dividing by 0, so it doesn't work. You just can't. You can't use any of the variables. You can't insert variables into your thing. So then we're going to have 1/2. What's the integral of sine? Negative cosine. So we're going to have negative 1/2 cosine. Instead of u, I put x squared back in. It's good. Let's do one more. You try it. If you get it right, then we'll go on. Then we'll stop.
Are we gonna have one more?
Nope.
I love it.
It's the weekend.
Thank you.
And it's 2 weeks till Christmas, and like Hanukkah's coming, right? Sorry.
What does this say? I think the 10th.
Terrible holidays.
I'm excited. This year,
It's like, yes, I am.
Alright, try this. When does Hanukkah start?
21st, I think.
It's so much better when it starts close to Christmas like that.
I agree. Because then, on
It will go through Christmas. It's like 7 days, right?
then on Christmas Eve you still get presents, and then on Christmas night you get presents. It's not all about presents. But it's but it's about
And
spending
my
time with your family and doing the candles and stuff. I love
candles.
Jeez, Mom.
Good presents, wafers.
You're so
I'm trying to sell my. I have like 7 boxes and 4 boxes in my house.
You have
Why?
7 boxes, but adding in 3 wafers.
How many? Where
did.
No. Well, yes. I thought it worked, but it doesn't. It was working like a week ago.
I doubt it.
That's how it's gonna go.
I doubt it.
Like me, Jim. Mom.
Mom, hit Jim. Mom.
I'll do it for you. Not gonna. You just fall to the ground.
What if I had
Do it.
disorder where
For real.
I got hit,
He
like
just
I'm like just shocked. Wow, this is annoying.
Break his wrist.
Yes. I forgot to plug for it.
Are you not talking?
Mac asked a question.
I don't think you were just you're talking
You know what? I don't even know.
I can tell.
Why? I wrote huge. Did you get it?
Yeah.
Yes, got it. Wait a second. Luke, you got it right. I did get it right.
Stop it, he's trying.
It's a lie. You got it right.
Use any what?
I did get it right, but I don't know how to
You do get
multiply
it.
fractions.
I reduced.
Okay. I got it.
I feel your pain, man.
Fractions are